I'm going to show you how to use the buffer storage function available on the MDL series DC electronic load. Buffer storage operation allows the user to store measured voltage and current readings temporarily into internal buffer memory, which can be retrieved with remote commands to a computer. The main advantage of this operation is speed, because all measurements are directly stored into the internal buffer without any additional post-processing time, which is existent when querying measurement data using USB, GPIB, serial and Ethernet interfaces. The MDL series can store up to 1,000 readings of voltage or current, or 500 readings with both voltage and current, at a minimum interval of 0.2 milliseconds. Buffer storage operation cannot be set up from the front panel. All of the setup and initialization is done remotely. In this video, I will be using the GPIB interface to configure the DC load for buffer storage operation. For convenience and demonstration, I will use LabVIEW software to show you how it works. The first thing we need to do is select GPIB as the interface for remote communication. Here's the order in which to send the commands, and I will explain each in detail. I have LabVIEW now in front of me, and have written a VI for all of the buffer operation commands. So the first command I send is *idn query. I have a LabVIEW initialize VI that will send this to query the instrument's ID and check to verify the ID. The next command I send is the channel selection command CHAN-1, which is the command to select channel 1. Always send this command first before all others because they are channel specific. Programmatically, the load needs to know which channel you are selecting to make the configurations. We then set the trigger source to bust by sending trig::sour_bus command. This will allow us to send a software trigger to initiate the operation later. Then I send a trace clear command trac::cle. You want to send this because this will clear out any previously stored data that might have been temporarily stored in the buffer. Next, you want to set the number of points or readings to store. The maximum is 1,000. For this example, we will set it to 100 and send the command trac::poin:100. The trace feed command trac::feed should follow after. This tells the load which type of data you want to store. Send trac::feed VOLT if you want to store only voltages. Change VOLT to CURR if you want only current readings. Or change it to TWO if you want both. However, if you select TWO, the number of points or readings configured earlier will be half. For this example, that would only be 50 readings, half of 100. Now we will just set it to VOLT for voltage readings. Buffer storage operation begins after receiving a trigger. If you want to add a delay after the trigger before the operation begins, send the trace delay command trac::del. You can delay up to 3,600 seconds. We will set it to 5 seconds by sending trac::del:5. You can control how quickly subsequent readings get stored into the buffer by specifying the storage operation time interval with trac::tim command. You can set it to as fast as 0.2 milliseconds or as slow as 3,600 seconds. The main advantage of using buffer storage operation over data logging via PC remote control is speed. But for the purpose of showing you the effects of the interval time, I will send trac::tim:1 to set the interval to 1 second between each reading. The last parameter we can configure for the buffer storage operation setup is filtering. You can enable or disable filtering of the readings captured into the buffer with trac::filt command. I will leave it disabled by sending trac FILT space 0. Before we can send a trigger, we need to send TRAC FEED CONT space NEXT command, which configures the load to await for trigger status. Then, finally, send the *TRG command to send the trigger. After the trigger delay 5 seconds, the operation begins, and you can query the status of the operation by sending TRAC FREE query command. The return value will have two numbers separated by a comma. In LabVIEW, I have already parsed this data. The first number tells the number of points remaining for the buffer storage operation to complete. The second number tells how many readings are stored. When operation is finished, the return value will be 0, space 100. If you selected to store both voltage and current, it would be 0, space 50. Now to query the stored voltage data, send TRAC DATA ? Make sure you set enough bytes in the read buffer to read all the data. Each readings will be separated by a comma. If voltage and current readings were selected, it will follow the format of voltage space current, and so on. In my LabVIEW example, I parsed the commas and put all the readings into an array.